Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so for today, we are going to continue our hypothesis testing, but for today is for the difference between two population mean, specifically for independent sample first. Okay, before we go further, let's take a look into the overview of the hypothesis testing for independent sample. Okay, if you still remember during our estimation topic, okay, we already covered into the estimation for independent sample, right, which we have 4 different cases. So it was same goes to this topic. For hypothesis testing, we also have 4 different cases to test on the difference between two population mean, which is for independent sample. Okay, for case number 1 is when we know the population variance, okay, for both population 1 and population 2. And for the case number 2, the population variance sigma 1 square and sigma 2 square are unknown, but the sample size are large, which is greater or equals to 30. The third case, we does not know the population variance for both population, but we assume the variances are not equal, and the other condition is the sample size are small, which is less than 30. And then the last case, we assume that both population variance has equal variance, and also the sample size are less than 30. Okay, so for the first two cases, case 1 and case 2, we're going to use Z test, and case number 3 and 4 we will use T test. Why? The differences here is in terms of the sample size. Case 1 and case 2, a large sample size. Case 3 and case 4 is small sample size. Okay, so let's take a look into case number 1 first. The population variance both are known. Okay, so we're gonna repeat the same step. Okay, we will have 5 compulsory steps to conducting a hypothesis testing. Okay, so for null and alternative hypothesis, for the difference between two population mean, the hash knot is we state as mu1 minus mu2 equals to 0. And then for the alternative hypothesis, we have left tail, right tail, and the two tail. Okay, so for the left tail, mu1 minus mu2 less than 0. Right tail, mu1 minus mu2 greater than 0. And for the two tail, we have mu1 minus mu2 not equal 0. Okay, so the definition of mu1 and mu2 tu is depend. Okay, so kalau awak diberi ada two company, it can be company 2 minus company 1. It also can be company 1 minus company 2. So make sure you state the correct hypothesis lah. Okay, based on the question. Okay, so step number 2, the test statistic. Okay, we're going to use Z. So Z equals to X bar 1 minus X bar 2 minus D. Okay, divide by sigma 1 square over N1 plus sigma 2 square over N2. Okay, so I want to highlight here. Okay, the value at this value for D, it can be number, okay, but this number is depends on, okay, let's say if the question asks you to test the difference between two population equals to 2, katakan, okay, dia kata population 1 minus population 2, adakah different dia 2? So maksudnya kat sini kita tak boleh buat kosong, kita kena buat value dia 2. So value kat ujung ni nanti pun kita akan ganti dia dengan 2. Okay, so kalau dia tak bagi tahu value dia berapa, kita just tulis kosong. Okay, ingat tapi kebiasaannya kita tak state lah berapa difference tu. Biasa kita akan buat kosong sahaja. Okay, step number 3 is critical value. So for the left tail, we have negative Z alpha, right tail Z alpha, and for the two tail, we have plus minus Z alpha over 2. Okay, and then step number 4 for the decision rules. Again, for the left tail, we reject hash knot if Z less than negative Z alpha. For the right tail, reject hash not if z greater than z alpha. And for the two tail, we have two conditions. Either z less than negative z alpha over 2 or z greater than z alpha over 2. Okay, the other one, we can use p-value approach also, where the decision rule is we reject hash not if p-value less than or equal alpha. And the last one, we have to make a decision and conclusion. Okay, let's look into example 10. Okay. The alkalinity in milligram per liter of water in the upper reaches of rivers in a particular region is known to be normally distributed with standard deviation of 10 milligram. Alkalinity reading in the lower reaches of rivers in the same region are also known to be normally distributed but with standard deviation of 25. Investigate at the 1% level of significance the claims that the true mean alkalinity of water in the upper reaches of this river is less than in the lower reaches. Okay, so kalau tengok dekat first sentence tu, apa yang dia dah bagi kat kita? Dia bagi kat kita value standard deviation of the population. Okay, so untuk upper reaches, standard deviation equals to 10. Untuk lower reaches, standard deviation equals to 25. So that's why here menunjukkan ini adalah kes yang pertama. We know the population standard deviation or population variance. Okay, but in the table it just give you the information on the value of the sample size for each population lah, for upper reaches and lower reaches. Okay, let's look into the solution. Okay, so now kita kena buat 5 step lah. So step yang pertama, you need to state the null and alternative hypothesis. Okay, so hash note kita adalah mu1 minus mu2 equals to 0, and h1 is mu1 minus mu2 less than 0, because tadi dia kata apa less than lower, right? So tengoklah, you define mu1 tu apa, mu2 tu apa. Okay, so mu1 kita adalah upper reaches, mu2 kita adalah lower reaches. So tadi dia kata upper less than lower. Okay, so that's why saya buat mu1 minus mu2 less than 0. So this one is, we are referring to the left tail. Okay, step yang kedua adalah kita nak calculate the test statistic. So the test statistic here is z equals to x bar 1 minus x bar 2 minus d divided by square root sigma 1 square over n1 plus sigma 2 square over n2. So finally we get the value is negative 2.5738. Okay, so kalau perasan sebelum ni, kalau left tail value dia mesti negatif. Selalunya macam tu lah. Kalau right tail value dia mesti positif. Kalau two tail, it can be positive or negative. Okay, so step number 3, state your critical value. So since this one is the left tail, so our critical value is z alpha. You don't have to divide alpha by 2 because this one is left tail. So alpha is 0.01. So you should look into the table z. Negative z 0.01 equal to negative 2.3263. Okay, don't forget to put negative. Okay, and then the decision rule, we will reject hash not if test statistic is less than negative 2.3263. Okay, so kalau tengok dekat figure ni, dia dah lukiskan dah rejection region dia, betul tak? Okay, okay, saya lukis okay, this one. So since kita nak tengok left tail, so this is our rejection region, yang mana critical value dia adalah negative 2.3263. So kita nak tengok value test statistik kita tu falls in the rejection region or not. So since we get negative 2.5738 which is false in the rejection region, so we will reject the null hypothesis. Okay, kalau tak lukis ni, kita tengok, kita compare value dia lah. Kita akan reject test statistic, reject hash not if test statistic less than negative 2.3263. Okay, so since we reject null hypothesis, so the test is significant. So we can say that there is a significant evidence to indicate that the mean of alkalinity of water in the upper reaches of this river is less than in the lower reaches. Okay, now kita tengok pula untuk case yang kedua, which is population variance unknown but the sample size is large, which is greater or equals 30. Okay, the step dia, dia punya hypothesis dia sama, critical value, decision rules, and conclusion dia pun sama. Cuma saya nak highlight kat sini dia punya test statistik. Test statistik dia berbeza, x bar 1 minus x bar 2 minus d over s1 square over n1 plus s2 square over n2 square root. Okay, bezanya sebab kita tak tahu kan. So, dia punya formula dia adalah s instead of sigma. Okay, let's take a look into example 11. Okay, suppose Amy record the time she took to reach her workplace by bus for 45 days. The mean times 36 minutes with standard deviation of 10 minutes. Amy then used monorail for 30 days and the mean time was 20 minutes with standard deviation of 3 minutes. Conduct a test of hypothesis to determine whether the travelling time by bus is significantly longer than travelling time by monorail. Okay, so ni kita nak test bus longer than monorail in terms of time. Okay, time taken by bus is greater than time taken using monorail. Okay, so our hash naught is mu1 minus mu2 equals 0. H1 mu1 minus mu2 is greater than 0. So this one is right tail. Okay, so tadi memang soalan tanya kan, bus greater than monorail. Okay, secara logik ni pun biasa monorail lagi cepat. That's why kita buat sign greater. Okay, so our test statistic, substitute into the formula, we get 10.0746. Okay, and then our critical value, since this one is Z and right tail, so critical value kita adalah Z alpha. So alpha kita adalah 0.05, so we get 1.6449. And then we want to state the decision rule. Okay, the decision rule should be reject hash naught if test statistic is greater than critical value. Okay, kalau kita lukis, since this one is right tail, so right tail, this one is the rejection region with the critical value 1.6449. So kita akan reject hash naught if test statistic is greater than 1.6449. So kita dapat test statistik kita 10.0746, which is greater than 1.6449, and that value is false in the rejection region. So our decision and conclusion is we reject hash naught since 10.0746 greater than 1.6449. So there is significant evidence to indicate that the mean travelling time by bus is significantly longer than the travelling time by monorail.